So I really like the title. Thank you, Fabian, for that, because actually it reflects what BHTOM is about. You just sit back and relax, and the robots are doing their job. Kind of, because we have both robotic and manual telescopes. So there are also humans behind everything what we are doing. So I'll be talking about this portal, the system we built. Just a couple of faces of people involved. We work at the University of Warsaw, National Center of Nuclear Research. There are some people involved. So Katarzyna was mentioned in Lindy's talk. She's now a postdoc. She was my PhD student. So we keep these connections close thanks to some people interactions. There is some funding. ACME is the main source of funding for us as well. Okay, so what is BHTOM? BHTOM, it stands, it is, I think it can carry multiple, it could describe multiple things. Okay, so something what we call BHTOM telescope network. Let's start from that. It's a global telescope network we've built for Gaia alerts. I was involved for many years in the Gaia alerting system at the University of Cambridge. We've been sending alerts and then hoping to get science out of it. But then early on, we realized what's the point of sending alerts if no one is following them up, right? So this is the problem we have these days, even larger. We started Gaia like 2 decades ago. And now this problem is even more severe. So hence this network was established, and now Gaia is gone now, unfortunately, but the sky is still being active and even more active the better telescopes we have. So the network currently comprises of 150 telescopes with different sizes. Some of them are manual, some of them are robotic. They're distributed all over the globe. So some of them have good weather, some of them have very poor weather. If you look at especially here in Europe, right, we have telescopes. There's many of these telescopes in Europe, actually. Many of them established a long time ago, and the weather there is pretty poor. But then the more telescopes we have, the more these clear nights we can extract from the nature, right? Most of them are volunteering. That's a thing to emphasize. They are just volunteering with their observing time, right? Occasionally, we need to write some proposals. We used to collaborate with Loiano, for example, in Italy, beautiful telescope. We used to have this kind of rolling proposal. And I've been sending my students essentially every month for a week of observations to an observatory where you can order call a pizza delivery and they bring it to your telescope. But most of them are just observing whenever they can, right? Given the bad weather, they can observe tonight, and then they can have a row of days when they cannot observe at all. Some of them are essentially giving us a small fraction of time, essentially filling the queues, the programs with targets we propose. And some of them are essentially observing for us, for example, whenever the clean night is there. And is your telescope there? That's the question to you. And if you have a telescope or you know of telescope, which is not here yet, I invite you to get in touch. Here's a gallery of some of them. You might recognize some of them, but it's a mixture of professional telescopes, some very old. We have a telescope next to London, for example, which is 100 years old, and it does a pretty good job, actually. And there's also a growing number of amateur telescopes, which are very good in terms of quality and the data they can deliver. There are schools having telescopes as well. There are outreach facilities as well. So we include them all. Some of them, as I said, are robotic and robotized or remotely controlled. Some of them are operated purely manually, and it doesn't matter from my point of view. So the BHTOM itself is a web portal, essentially. So the TOM there in the name is Target and Observation Manager, as you can imagine, as Lindy introduced. So the origins of BHTOM are embedded in TOM Toolkit. At some point we forked out, but now we want to come back to the roots. So we've developed some things which are not in TOM Toolkit, and then TOM Toolkit has some features we don't have. So that's why we are now working on getting back together. So it has all the features of, not, as you said, not all of them, but many of the features of the TOM. So it can handle the automated observation requests. But I think what matters in our system is that we can process the raw images from these heterogeneous units, right? So we kind of coordinate these 150 telescopes. We tell them what to observe, and we propose, actually, we suggest what they can observe, and then they send us the data whenever they collect any. And then we standardize it. We also query the archives, which is also a TOM feature, and then we provide it back to users. So I have a schema I'll quickly go through just to draw the picture here. So there are the surveys, and I listed Gaia there, but it's just for historical reasons because I'm so emotionally attached to that. But you can imagine there are targets flowing from these. And then, of course, I didn't draw it here, but they go through brokers, right? Everything goes through brokers these days. And then it reaches users, and the users can ask multiple questions. So if someone is interested in this quasar and they want to observe it for 1 year, someone is interested in a comet, right? Why not? It's a time domain target, which we need to observe for a short period of time. And then there is a supernova we want to observe now, right? So this is what we broadly call the time domain targets we can cope with. So I emphasize this, we are not limited to transients per se. Only we can, we are interested in quasars, anything time domain, and it's a very broad definition of time domain. So that all goes to our system in forms of created targets, observing requests, and then so we communicate with the network of telescopes, right? So we give them these targets of interest, and then they send us the data back. I'll zoom it in here. Many of our telescopes are now slowly switching to EON, and they use the LCO's observatory control system. So once they have it, it's even easier to communicate with them, because this is, again, this is the intrinsic feature of TOM, that it's EON compatible. So we are expanding these for the robotic telescopes, but also there are many manual as well. Data is also coming from the archives, and there's many time domain archives. I stress that it's very often, okay, maybe not to this community, but it's there, right? So, and in terms of archives, I also mean living archives like Atlas, ZTF, Gaia is dead now, but Ogle and others. So providing time domain archives plus the current observations. So we query these, and we combine it all, and this is the science-ready data. We give it back to our users. So it combines the archival and follow-up observations, right? And then the users can focus on the publications, of course. And everything here can be scripted. All this data flow, it's an intrinsic feature of TOM, maybe except writing publications, but you never know these days. So just a few slides on the data processing. So as I said, we do the full automated data processing. Once we have a telescope registered in our system and tested, essentially, we need to go through each telescope separately and have it tested, whether it flies through our system. Then it can be all automatized, and then the PSF and aperture photometry is done uniformly for all the telescopes we have. And then the data is standardized. So we process the whole frame. We derive the best filter matching. So if you have a non-standard filter, we can also deal with that. That's why we are open to amateurs who often use RGB cameras, right? We can also handle that. And then we derive the photometry for all objects on the image, right? Maybe you're interested just in this supernova there. However, as a side product, we also obtain the photometry for all these other targets, and we actually store it. And then the data is downloadable for everyone who's registered. Right, here's some examples. It's a light curve of a supernova or a planetary microlensing event where the data is coming from these various telescopes that you can tell, at least by eye now here, that this light curve is coming from different telescopes, different bands, different filters are denoted with different colors. Some other science cases, again, supernova, again, microlensing, but also we are open to variable stars. There is a large community of young stellar objects, for example. They monitor them for years, and there are very interesting stuff coming out of it. A few words about the API, and everything is scriptable, as I said. So then there are scripts for the data flow to and telescope. You can get the observing requests. You can upload the images automatically. And Astro-COLIBRI is the first example that as an external system which is using our API. So then you can essentially click a button, submit the event to BHTOM. It creates a target in our system. with some predefined characteristics, and then our telescopes, they can see that target and they can decide whether they want to observe it or not. And when they observe, the data is coming back to our system, and we hope this week it will also be coming into the Astro-COLIBRI as well. We provide scripts for that. There is an extended manual. Recently, we installed a chatbot. You can talk with, ask chatbot how to do things. I will show an example, something what is open to, which is actually bringing BHTOM closer to amateur community. So this Prism website, and it's called Vivona, so that it's beautifully, essentially, it's a beautiful example of using the API we have and essentially wrapping the obscurities of BHTOM into some nicer wrapping, and it's accessible through a tool which is known to amateur community. So this also emphasizes this is something what we'd like to do in Astro-COLIBRI as well. So you might be using BHTOM not even realizing that. Why should you learn all of these so many tools when you can just stick to your tool you're most familiar with, and then just use it, use the functionalities we offer in BHTOM without even knowing it. Just one word about the foundation we established recently. It's called EAST. So it's kind of a funny phrase, an European Astronomical Society of Small Telescopes. This is something what we realized fairly early when using BHTOM, that there's many amateur applications and also telescope owners who can contribute to science, but they don't know how to do that, right? And they need a lot of support. So we thought that a foundation is probably a good body to take care of it. It also gives us, it opens up some possibilities for funding, right? So as a foundation, an NGO, we can essentially go to Ministry of Education, for example, and ask for some funding, and we avoid all the admin hassle through university, for example. So that's why the foundation, and we call it citizen science. This is something what we invite people to, essentially how to use small telescopes in science. And BHTOM is, again, as I said, is this tool people use, and we train people how to do the observing and how to use BHTOM within this framework. We coordinate the data exchange between professionals and amateurs. We also expand the network of telescopes for science outreach and potentially into space industry where the money is. We work on enhancing telescope technology and also protecting dark skies, which is a problem for professionals. Of course, it's natural, it's there, but for amateurs, it's even more severe. They're more affected by this problem. Of course, we seek new partners, ideally some institutions which are interested in joining us. Something what we also realize is that people often, especially the amateur communities, they prefer working in their own language, their own culture of ways of doing things. So we have a couple of people whom we call ambassadors, and there is actually an ambassador for France, Lithuania, Turkey, South America, New Zealand, and Italy. And so these are people who know the environment, they know how to talk to people locally, and they spread the information about our foundation, and they involve the local communities into our foundation. There's a list of some science partners. It's nice to show them, but that's natural. And I stop here, and thank you very much.